Assalamu alaikum everyone. Welcome back to Easy Taleem. Today we begin what is probably the most important chapter in the entire AS math series, calculus. For many students, this is the chapter they fear the most, not because it is difficult, but because nobody ever explains what differentiation actually means. They simply tell you to differentiate or find the derivative, right? So these are the words that scare students the most. Apply the power rule, find the stationary point, right? So power rule, chain rule, stationary point. Students memorize rules and then Cambridge changes the question and everything falls apart. Today we are going to do something different. Today I want you to understand why differentiation exists in the first place. Once you understand the idea, the formula become almost obvious. All the formulas. By the end of today's lecture, you'll understand why was it invented. We are going to answer the question why. We are going to find out what a derivative actually measures, what it actually does, the action of it, right? We are going to find the average gradient versus instantaneous gradient. So instantaneous gradient is the derivative or the dy by dx, right? So we are going to find out the difference between instantaneous gradient and the average gradient as well. We are going to do the first principles, the power rule, differentiating any polynomial, and we are going to solve the first Cambridge questions on differentiation. And here's the good news: we're only 4 lectures away from completing the entire 9709/12 AS mathematics syllabus. Functions, coordinate geometry, circular measure, trigonometry series is all done. Now comes calculus, so let's begin. Now, so the first question of why was differentiation invented. So imagine you're driving, your friend asks you, how fast were you driving? You reply, I traveled 120 kilometers in 2 hours. So you start here, you spend 2 hours and you are able to cover a distance of, so this is time 120, right? So let's say, so this is the journey on a speed time graph, right? Or this is distance time graph, by the way. Now, what is the average speed? That's very simple, distance upon time. So that is 120 upon 2, right? 60 kilometers an hour. But were you driving at exactly 60 kilometer per hour every second? So you started here. Did you jump onto 60 kilometers an hour right away, or were there instances when you were going 70 kilometers an hour and there were speed breaks as well, there were turns and you were going 30 kilometers an hour, you were at a traffic light and all of that, right? So you were able to, or you managed to complete 120 kilometers, right, in 2 hours, but your speed wasn't constant like a straight line. So your speed was varying like this, right? Now, the gradient of a distance time graph, as you know, is a speed, right? Change in distance upon change in time is the speed, right? Now, sometimes you were traveling at 80, other times you were traveling at 40, sometimes you stopped at the red light. Average speed hides what actually happened, right, throughout the journey. Now, suppose your friend asks you exactly how fast were you moving at 17 minutes past when you left your house, right? At, let's say you started at midnight, so, and this is 2 a.m. So how fast were you traveling at, let's say 17 minutes past midnight? Suddenly average speed isn't enough. Now you cannot just do total distance upon total time taken and just answer him that okay, it was on average 60 kilometers an hour. No, you have to find the gradient at exactly this point, right? So now you need the speed at one particular instant, which is called the instantaneous gradient. Now, that is the birth of differentiation. Differentiation measures the rate of change at an instance, right? So, if the graph is going like this and you want to find out the gradient at this particular point, so how do you do that? You are going to do that by putting your ruler around it or just tangent to it and finding the gradient of this line by finding out 2 points on this straight line that you do, right? Now, there is a chance of error when you are trying to do it physically by hand, but when you try to do it algebraically, invoking the principles of differentiation, there is no margin of error, right? So differentiation measures the rate of change at an instant. Okay, not over an interval. We are not saying that you find the gradient between this interval. We are not saying that. We are saying you find out the gradient at this instant x naught. So at one exact moment, this idea appears everywhere. Population growth. When was so back in 2017, how was the population growing in a particular country? So you're not averaging the growth over an interval, you are trying to find it out over a particular instance, right? Now economics, physics, the quantities, the change in quantities in physics, medicine, how much dose affects how much does it go in the bloodstream, what effects does it how much effect can be calculated after 3 hours of administering it, and all of that. Engineering, the precision matters, right? Artificial intelligence, everywhere. Now from functions to graphs, everything we've studied until now connects beautifully, right? So we did functions, we connected it to coordinate geometry, right? And from there we went to the graphs. And now imagine this curve. Suppose I choose 2 points. Now let's say you have a quadratic curve, right? Now let's say that I choose 2 points here, A and B, connected by a straight line. So let's say that this point is B and this point is A. If I calculate rise over run, how can I do that? I will draw a horizontal line here. I will draw a vertical line here. Wait a second, let me just try to do it nicely, and let's just try to make the axes nicely as well, right? Because we are going to explain some very nice concepts using this diagram, the secant line and the tangent line. Okay, now the gradient of this line is going to be this rise over run, right? So I obtain the gradient of this secant line. Let's call it the secant line. Okay, now you already know this, that gradient equals to change in y. So this is change in y, the change between this, the vertical change between the y coordinate of B and the y coordinate of A. So this is change in y, and this is change in x, the difference between the x coordinate of B and the y and the x coordinate of A. This distance is change in x. So when you take the ratio of that, you get the gradient represented by a small case italic m, change in y over change in x, or y2 minus y1 over x2 minus x1, or rise over run, as you will have remembered it from your GCSE and O levels, right? So it's simple. But what if I move B closer to A? What if I start moving this point from here closer and closer and closer to A? Right? What happens then? So if this, let's say that I move this point from here, I move it to here. Now what happens is I get this point B here, so I can draw my secant line from here to here. Wait a second. Right? So this is my secant line, right? Eventually I want my B point to come closer and closer and closer to A, such that both the points almost become one. Now what happens? So if this B point further comes nearer and nearer and nearer to A, let's say that now I draw it even further closer to A. Let's say that my point B is now here, and now when I join these 2 points, this point and this point, by my secant line, so this is almost tangential to the line that I want to draw at A. If the distance between A and B, if the distance AB gets closer and closer to 0, that means that the horizontal distance between them is approaching 0, right? By limits concept, we say that x2 minus x1, if I denote it by h, this approaches 0. So x1 is almost equivalent to x2. So that the secant line is now, so when it happens, the secant line gets converted into a tangent line, right? I hope this is making sense to you, right? That tangent has one gradient at particular point A, right? So that gradient is called, that particular gradient of the tangent line which got transformed from the secant line into the tangent line, because of the reason that your x2 was moving closer and closer to x1 such that this secant line was, so this point was moving from here to here, from here to here, and closer and closer and closer to here, such that now you are able to form a tangent at this point A, right? So the gradient of now this line is going to be the derivative using the calculus principles, and this is what differentiation finds. So now, what's the difference between average versus instantaneous gradients? Let's make this crystal clear. Average gradient is between 2 points, so average gradient is going to be at 2 points, and instant gradient is going to be, or the dy by dx or the derivative or the differential is going to be at one particular point. This is secant and this is tangent. Okay, Cambridge loves asking conceptual questions because of based on this. So if you understand this picture, you'll never confuse the two again. This is why differentiation isn't a random formula. It answers one question: how steep is the graph exactly here? So let's say, okay, let's make nicer graphs because, okay, so this is the vertical axis, this is the horizontal axis. Let me use a sharper pencil here. So let's use the red, and there is, okay, so this line. So if I say that this point, so let me say that this point is A, which is x1, and or rather this is x and y, right? And if I take another point B here, right, and if I call it, so this is x, and let me say the distance, the horizontal distance between A and B is h. If this is h, then the x coordinate of B is going to be x plus h, right? So, and let me say that this is x naught and y naught. So this is x naught and this is x naught plus h. So this is going to be x naught plus h. And let me say that this is not y naught, this is f of x naught, right? So the output value at A is going to be f of x naught by functions, right? And the, oh my god, and the output value at B at f of, at input value of x naught plus h is going to be f of x naught plus h, right? So the output value is going to be the, is simply going to be this, right? Now I can draw a secant line here connecting A and B, but this is not going to give me quite the desired result. If I want to find out the gradient at this particular point A, so this is not the gradient at point A, right? The gradient at point A is going to be something like this, right? But I can obtain it if I start moving this point B closer and closer and closer to A, right? And how does that happen? If this h, the distance h, gets closer and closer to 0 such that x naught and x naught plus h almost becomes equal, right? So we are trying to make this distance between them 0. So by algebra, what is the gradient? The gradient is going to be this. Change in y is f of x naught plus h minus f y, which is f of x naught over the distance, the horizontal distance, which is nothing but h, right? Now this is the average gradient between 2 points. Now if I say, if I apply limits concept on it, so instantaneous gradient or the dy by dx is going to be equal to, if I apply the limit h approaches 0. So if h is approaching 0 of f of x naught plus h minus f of x naught over h, then this is the definition of a derivative. Okay. Now Cambridge doesn't ask you to use the limits concept and all of that in order to derive it, but you must understand it, right? Now, where does the famous differentiation formula come from? So a lot of teachers are just going to write that if y is equal to x squared, dy by dx is going to be, you bring this power down as a coefficient, make it 2 and reduce the power by 1. So this is going to be 2x, right? But where does this 2x come from? Now, what we are doing is, you want to find out the gradient for, so if f of x is x squared and f of, so what is going to be f of x plus h? It is going to be, so one coordinate is going to be x comma f of x, the other so let's call it a, the other coordinate is going to be x plus h comma f of x plus h. Agreed? So this is going to be x plus h whole squared, right? Now let's find the gradient. So average gradient is going to be change in y, so this minus this is going to be f of x plus h minus f of x over x plus h, which is this, x plus h minus this minus x. So this cancels. So so we already know that the distance horizontal distance is nothing but h. Now if average gradient is this, so f of x plus h is going to be x plus h whole square, and this is going to be x square, and this is going to be h. So this becomes x square plus 2xh plus h square minus x square over h. So this is going to become 2x plus h is equal to the average gradient. And now if I apply the limit concept to it, so this is going to convert into instantaneous gradient, which is going to be dy by dx. So I apply the concept of limit h approaches 0 for 2x plus h. So now if my h becomes 0, so I am only left with 2x, and this is the derivative of x squared. So this is where this comes from, right? So we are saying that h becomes smaller and smaller and smaller such that it is approaching 0. The average gradient turns into the instantaneous gradient, which we denote by dy by dx, and this is exactly why we define limit as h approaching 0. This is called first principles. Okay, so this is first principles. Every differentiation formula comes from this one definition. Today you are not memorizing differentiation, you will understand it, that why do we get the result what we do, right? Now let's do an example. So we already did an example for x squared. Let's try to do for x cube. Yeah, let's do it for x cube. So if fx is equal to x cube, then you, by the way, so if the derivative of y, if y equals to x cube, the derivative of y may be denoted by y prime or dy by dx. So this power comes down, this becomes 3, and power gets reduced by a single, so this becomes 3x squared. Now similarly, the derivative of fx may be written as f prime of x. So this is same as y prime, this is same as dy by dx, and so all these notations are one and the same thing. Now why is the derivative for x cube 3x squared? Let's prove it by first principles. So f of x is equal to x cubed, and therefore f of x plus h is going to be equal to x plus h whole cubed, which is nothing but h cubed plus 3x square h plus 3x h square plus h cubed, right? Now, so we have got two coordinates. A coordinate is x comma f of x, and b coordinate is x plus h comma f of x plus h, which is this entire thing which I don't want to put in here. So this is x plus h, right? F of x plus h. So if I want to find out the average gradient, I'm just going to find rise over run between b and a, right? So this is f of x plus h minus f of x. So if I subtract this from this, so I get these three terms. So this is 3x square h plus 3x h square plus h cube, and the difference between the horizontal coordinates is nothing but x plus h minus x, which is nothing but h. Now if I want to convert this average gradient into instant gradient, or dy by dx, or f prime of x, or y prime, this is nothing but you apply the limit concept where h is approaching to 0. First of all, you cancel the h in the numerator and denominator, so you are going to get 3x square plus 3xh plus h cube, right? And now you apply the limits to it. So as h approaches 0, this one becomes 0 and this one becomes 0, and there is no h here, so this just becomes 3x squared. So this is going to be the derivative of y equals to x cube. It just becomes 3x squared, right? Now you can just repeat the pattern. This is going to appear again and again, which leads us naturally to the power rule. So now remember this, now that you have known where this stuff comes from, you can now remember it. So if you're given ax to the power of n, so if you apply the, wait a second, if you apply the derivative function to both the sides, so this constant a can come outside. So this becomes, so d upon dx stays as it is. This constant term you can write outside of it because nothing happens if it's getting multiplied to it. And we have x to the power of n here, and we can write down dy by dx here. Now, when you apply the derivative on a variable, what happens? This power comes down, becomes a coefficient, so n comes here and one power gets reduced. So the answer is a n times x n minus 1 is the derivative of a times x to the power of n. So this is the derivative of this function, right? I hope you guys are taking notes. So this single rule saves enormous time. This is the rule you'll use in almost every P1 question, but unlike many students, you now know where it came from, right? Now, basic differentiation rules. Let's do a few examples. So if you're given y equals to 5 multiplied by x to the power of 7, then dy by dx is going to be equal to, you multiply 7 by 5, so this becomes 35. X, one power gets reduced, so this becomes 6. Now, if you're given y equals to negative 7 x to the power of 3 upon 2, now what happens here? So dy by dx is going to be equal to your 3 upon 2 multiplied by negative 7 in order to give you negative 21 upon 2. And then one power gets reduced from here. 3 upon 2 minus 1 is just half, right? Now, let's do another one. If you're given y equals to, I don't know, 1 upon x to 1 upon under root 2x. Now, this is simply y equals to 2x to the power of negative half, right? Now, what happens here is, okay, let's not put a 2 here. We will do it later when we are coming to chain rule. So now this minus half comes here, multiplies by this 1, which is the coefficient of the variable. So minus 1 times 1 times minus half, and one power gets reduced. So minus half minus 1 is minus 3 upon 2. So the answer is going to be minus 1 upon 2x 3 upon 2 is going to be equal to the derivative of 1 upon under root x, right? Now, so these are the common mistakes that students make in fractional and negative power. So everything fits the same power rule, right? So one more thing. Now, if y is equal to 6, so now if you want to find out the gradient of this, y equals to 6 is nothing but a constant line, right? So this is 6. What is the gradient of this line? Nothing but 0, right? And you can prove it algebraically as well. So y equals to 6 may be written as y equals to 6 multiplied by 1, and 1 may be written as x to the power of 0 in terms of a variable, right? Now, when you differentiate it, 0 multiplies here with the coefficient, so this becomes 0, x, 0 minus 1. So this becomes 0 times x minus 1. But guess what? Anything that multiplies with a 0 becomes a 0. So dy by dx is nothing but a 0. And you already knew it that the gradient of a horizontal line is nothing but 0, right? Now, let's solve our first proper Cambridge question. Let's say you're given y equals to 2x cubed plus 5x squared. Now, if you want to find out the gradient of this, you apply the gradient function to both the sides and then you distribute it by this plus sign. So there is a y and there is a 2x cubed plus 5x squared. Now you distribute it by this plus, so this becomes d upon dx for 2x cubed and d upon dx for 5x squared. So this is 2x cubed and this is 5x squared, and this is nothing but dy by dx already. Now, the differential of 2x cubed is nothing but 3 multiplies by 2 to give you 6, and 1 power gets reduced, so x squared, and this 2 multiplies by 5 to give you a 10, and then 1 power gets reduced, so this is 10x, and this is your dy by dx, right? Now, so today we built the foundation, not just differentiation, but the calculus itself. Today you learned why differentiation exists, average versus instantaneous gradient, tangents, first principles, power rules, polynomial differentiation. I'm not going to proceed any further. We are already into 25 minutes of the lecture. I want you guys to go to your Cambridge Indoors books. By the way, if you don't have the digital copy of that, you can WhatsApp me on +92 329 3028485. It's easily available for everyone. for a lot of posts around around differentiation and all such topics. We have been uploading them on our Instagram for the live challenges, past paper questions, solution, a lot of reels on the wow factors of for all these topics. So you can also follow us on our Instagram, where we go by the name of Easy Taleem, EASYTALEEM. Right now, in the next lecture, we'll begin applying differentiation. We'll move from finding derivatives to using them for gradients of tangents and normals. Right, because so this was a graph of y equals to x squared. Right, you understood that the gradient of this graph is going to be 2x. But if I want to find out the equation of a tangent at this particular point, let's say that this is 2 comma 4, right? How do I do that, right? What if I want to find out the equation of a normal at this particular point? How do I do that, right? We know all the stuff, all the toolkit. We have the toolkit to find it out. I'm just going to combine all the concepts that you have learned already in the past 1 month of lectures that we have been uploading on YouTube. So hopefully you are following our us on our YouTube channel. So and we are also going to use this very principle, the very concept, in order to find out the turning point of any function, or the turning points of some other polynomials as well. You know how to find out the turning point of a quadratic using the completed square form. But now let's see if we can also do it using our first principle. Right now, these ideas dominate Cambridge paper 1. These are core P1 outcomes in the current 9709 syllabus. So if today's lecture helped you finally understand what differentiation actually is, you please subscribe to the channel, share it with a friend who's scared of calculus. Everything is available free of cost on YouTube. Instagram, like I said, has additional Cambridge questions, reels, and revision content. So if you'd like the Cambridge endorsed digital book, structured classes, or have any questions, you can reach out to me on my WhatsApp. I've given you my number here. I'm Irfan. Thank you for watching, and I'll see you guys in the next lecture on Saturday.